Any digital system will have a module or modules. The module will have a set of inputs and a set of outputs. So in VHDL, you have an entity and an architecture. Under entity, you'll have the module names, comma, port names, comma, direction, and type. The architecture is basically a description of how the module works. For example, let us try to construct this circuit. So the circuit has three inputs, A, B, and C, and one output F. And I'm going to name this circuit as my circuit. Okay, so the entity for the circuit would be my circuit, that is the module name. So module name is my circuit. The port names are A, B, C, and F because they are the input and the output ports. A, B, C, and F. The direction is A, B, C are input ports and F is the output port. And A, B, C, and F are all standard logic, which means they can take either a logic 0 or a logic 1. So all of them are of type standard logic. I'm going to explain more about standard logic in just a moment. The one thing that you need to remember about VHDL is VHDL is a case insensitive language, okay, which means that uppercase A is treated the same way as lowercase a. Uppercase Z is treated the same way as lowercase z. So it doesn't really differentiate between uppercase a and lowercase a. The second point that you need to remember about VHDL is, in your regular programming languages, statements in the program get executed sequentially. That is, you execute the first statement followed by the second, third, fourth, and so on. However, in VHDL, all statements are executed parallelly. Okay, let us begin writing our VHDL code. The first line in any VHDL code will be the library. So declaring the library is just like declaring your header files in C or C++ and packages in Python. So in this case, we want to use the IEEE library. And more specifically, we want to use the IEEE.std_logic_1164.all. We want to use this particular package, that is the standard logic package. In standard logic, you have 0, which stands for logic 0, 1, which stands for logic 1, have U, which stands for uninitialized, have X, which stands for unknown, you have hyphen, which stands for don't care, and finally you have Z, which stands for high impedance. Okay, so just remember that you need to include the libraries first. The next step is to have the entity. So you write entity, the name of the module. Remember, I named it as my circuit. Entity my_circuit is. Now you have to write the ports. Port. First write the input ports. So A, comma B, comma C, colon, in, which stands for the input, std underscore logic, semicolon, and F, which stands for out, std underscore logic, close the parentheses and put a semicolon, and then write end. Okay, so what the entity does is it's going to create a block. I mean, you cannot see the block, but that is what it does. So A, B, C, and F. So this is the entity, and this is the architecture, which relates to how the inputs are connected and how the inputs are logically connected to form the module. The next step is to write the architecture. Now in VHDL, there are 3 flavors of writing the architecture. Remember, every VHDL program must contain an entity and an architecture. Now the VHDL architecture, the first flavor is the behavioral model. So it is the high-level algorithmic description. So you can write your code using behavioral style. You can also write using structural style. It's basically a connection of modules. And finally, you have the data flow model. So you can treat your behavioral style of programming as something related to if-else and case statements. Your structural programming is somewhat related to your functions and function calls. And your data flow is logic equations or expressions. We are first going to look at the data flow model of writing your architecture, and then over the course of the semester, we'll learn about behavioral and structural as well.